are in West Virginia. Okay, so it's time for joke of the day. If towels could tell jokes, they'd probably have a dry sense of humor. I love it. I just love it. So let's take a look now at laws of exponents. And laws of exponents, I'm going to break it up in about 2 or 3 parts. And so this is the first part. We're going to take a look at 3 of our laws of exponents. There are actually 7 laws of exponents, and I'm just going to discuss 3 of them right now. So in order to discuss the laws of exponents, I want you to understand why they are the way they are. If I just simply gave you that law and said, okay, memorize this thing, it'd be a little bit challenging to remember it. But if you know where it comes from, then it makes sense, and one, the memorization is easier, or you might not even have to memorize it because it just makes sense. So the first of the laws of exponents is the product of powers property. And in understanding where it comes from, I'm going to ask you, what does 2 to the 3rd power times 2 to the 5th power mean? Now, I'm not looking for the law of exponents. I just simply want to know, what does just 2 to the 3rd mean? Yeah, 2 to the 3rd means 2 times 2 times 2. But now I'm going to multiply that to 2 to the 5th. And what does 2 to the 5th mean? Absolutely. It means 2 times 2 times 2 times 2 times 2. In other words, I have 3 2's multiplied here from the 2 to the 3rd. I have 5 2's multiplied here from the 2 to the 5th. I'm multiplying all these 2's together. Now, how many 2's are being multiplied together at this point? Absolutely. There's 8 of them being multiplied together. Now, what's the shortcut way to write 8 2's being multiplied together? Yeah, it would just be 2 to the 8th power. Now, incidentally, we can figure out what 2 to the 8th power is because we can multiply 2 times 2 times 2 all the way down, and we're going to get a 256 out of that. But I'm not that terribly concerned that you know that 2 to the 8th is 256. It's good if you know that. I'm more concerned with saying, okay, how do I get from a 2 to the 3rd times 2 to the 5th to a 2 to the 8th? In other words, I don't want to have to write this out every time, because especially, what if it's 2 to the 33rd and 2 to the 55th? I don't want to write out 33 of these 2's and 55 of these 2's. I'd rather just have a rule that will get me from here to here in one shot. Hopefully you're noticing that if I take a 3 and a 5 and I add them together, that will give me an 8. And that's what the product of powers property says. We have a product, a multiplication problem, of a couple of powers. And whenever you have a product of powers, as you see down here, what it says is, I'm going to keep the base, because it's all about the base, So I'm going to keep that base, and I'm going to add up the exponents. The key here is, we have to have the same base. If you don't have the same base, you can't do that. Because if this was, say, for instance, a 7 to the 3rd power times a 2 to the 5th power, I would have 7, 7, 7, and then 5 2's. I can't call that like a 2 to the 8th or a 7 to the 8th or anything like that, because they're different bases. So when the base is the same, because it's all about the base, and I'm multiplying those powers together, I'm going to add up those exponents, and I'm going to keep that base. That's what the product of powers property says. When multiplying same bases, we are going to add those exponents. So let's take a look at a couple of examples here. So if I have an x to the 5th times an x to the 6th, notice here the bases are the same. And that means I have 5 x's being multiplied together. I'll just go ahead and write it out. 5 x's being multiplied together. And then I have 6 more x's being multiplied together. 3, 4, 5, 6. In other words, I have 11 x's being multiplied together. So rather than writing it all out, I don't have to do that. I can just keep the base, because it's all about the base, and I can add up these 2 exponents. 5 and 6 will give me 11. So my answer is, in simplified form, x to the 11th power. Now, take a look at the next example. Notice that what this says is I have 2 times the 8 to the 4th, because remember, when things sit beside each other, that indicates multiplication. So I have 2 times the 8 to the 4th, 2 times a to the 3rd, times a b to the squared, another multiplication problem there. Negative 3 times a times b to the 3rd, another multiplication problem there. And notice what's happening right here between those parentheses. And right here between these parentheses. Yes, it's multiplication, because remember, when things sit up against each other, that indicates multiplication. This is one great, big, huge multiplication problem. Now remember, multiplication is commutative and associative. Because of that, we can reorder and regroup all that we want. So if that's the case, could I take, for instance, this 2 and this 2 and this -3 and multiply them together? And let's put the a's together, that a to the 4th, the a to the 3rd, and the a to the 1st power. The a here, the a here, and the a here. And then put those b's together, the b to the 2nd and the b to the 3rd, and multiply them together. In other words, could I reorder the way that I multiply? Absolutely, because multiplication is commutative and associative. And it's much easier to do this, because now I know that 2 times 2 is 4, 4 times -3 is a -12. And I know that when I do a to the 4th times a to the 3rd times a to the 1st, remember what I'm going to do here is I'm going to add up those exponents because I'm multiplying the bases. I'm going to keep the base because it's all about the base, and I'm going to add those exponents. 4 plus 3 is 7 plus, remember that's an understood 1 right there. So 4 plus 3 is 7 plus 1 is 8, so I get an a to the 8th. Now on the b's, again, when I multiply same base, I'm going to add up those exponents. So b to the 2nd, b to the 3rd, add them up, and I get a 5. Now, can I call this a -12 ab to the 13th? Right, I can't. Because remember, it's all about the base, These are not the same bases, so I cannot add those up. And so I am stuck, and that's as good as that one's going to get. So now, let's take a look at another of our laws of exponents. This is our product of powers property. And in other books, other teachers, they might call it a different name. Some will call it a law, like product of powers law or rule or whatever. But this is essentially what it amounts to is, how does it work? When I'm multiplying same base, I add up those exponents. So let's take a look at the second of our laws of exponents. Remember, there are 7 of them. So when we take a look at the second laws of exponents, I want to ask you, what does 2 to the 5th to the 3rd power mean? In other words, take that 2 to the 5th, raise it to the 3rd power. So basically what this means, it means take the parentheses, whatever's inside the parentheses, and raise it to the 3rd power. Oftentimes I'll put my hand over the parentheses so I don't confuse myself. So it means hand to the 3rd power would mean hand times hand times hand, which feels kind of weird, but that's what it means. Hand to the 3rd power would be hand times hand times hand. My hand happens to be a 2 to the 5th. So this is going to mean 2 to the 5th times 2 to the 5th times another 2 to the 5th. And we just learned, because of our product of powers property, whenever we multiply the bases and the base is the same, we're going to keep the base because it's all about the base, and we're going to add up those exponents. 5, 5, and 5 will give me a 15. Now, incidentally, 2 to the 15th, if I multiply 2 times 2 times 2 times 2 times 2, 15 of them, I'm going to get, I can't quite remember what that is. I'll have to come back to that one. Anyways, my point is not so much what it ends up as. My point actually, let's see, 2 times 2 is 4, times 2 is 8, 16, 32, 64, 128, 128 would be 256. Oh, it's getting too big. I'll have to come back to that. My point here actually is that when I don't want to have to write this out, because what if that was a 33? I do not want to write out 33 of these 2 to the 5ths. So instead of having to do that, I need a shortcut. I need a rule that's going to get me from here to here in one quick step. Hopefully you're noticing that if I just take a 5 and a 3 and I multiply them together, that will get me to a 15. And that's what my power of a power property says. I'm taking a power, I'm raising it to a power, the power of a power. And so what it says is when I take a power and I raise it to a power, I multiply those exponents. So again, I'm going to keep the base because it's all about the base, and I'm going to multiply those exponents. When raising a power to a power, you multiply the exponents. So this is what my property says. Now, a lot of people will get those two properties confused, and one of the ways that I've learned to keep it straight is, remember, when things sit up against each other, that indicates multiplication. This is sitting right up against that parentheses. So right up against the parentheses means I'm going to multiply those two exponents together. On the other law, or the other property, Remember, they were sitting so far apart, it's like I could put a plus sign between them. And the same thing's happening right here. They're sitting so far apart, it's like I could put a plus sign between them. That helps me to keep my laws and properties straight so I don't get them confused. So back to our power of a power property. Take a look at this example. It says I'm going to take an x to the fifth and raise it to the second power, which we do know would mean an x to the fifth times another x to the fifth, and if I add those up, I do get an x to the 10th, but I'm going to go faster by just simply multiplying those two exponents together, because when this sits right up against the parentheses, that indicates let's multiply them. So 5 times 2 will give me a 10, and that's how I get x to the 10th on that one. All right, so now we are down to our third law, and this is the last one we're going to look at in this video. This is my all-time favorite property, and yes, I actually do have a favorite property, because the power of a product property, let's talk about what it means. If I have an AB to the third power, again, what I'm going to do is put my hand over top of it so it doesn't confuse me. So if I have hand to the third power, then that indicates hand times hand times hand. But my hand happens to be an AB. So what this means to me is I'm going to take my AB and I'm going to multiply it to another AB, and I'm going to multiply it to another AB. And like we said before, because multiplication is commutative and associative, and I can reorder and regroup all I want, that means I can put my A's together like this, A times A times A. I can put my B's together like this, B times B times B. And A times A times A is A to the third. B times B times B is B to the third. So in other words, what I can do is I can take my power and I can distribute the power to every single factor that's inside. I know, I can't sing. I fully understand that. You are welcome to laugh. I laugh all the time at my own singing, but it's okay. You'll get used to it. So anyways, if I take a power or take a product and raise it to a power, then what I'm going to do is I'm going to distribute the power to every single factor that's inside. You see, I grew up in the 80s, and there was a great song called I've Got the Power by a group called Snap. There's my shout out to Snap. And back in the 80s, we were breakdancing with our mullets. We were having a big old time with our big hair. And we were distributing, and we weren't distributing the power. But anyways, it was I got the power. But here, because I'm doing some math, I'm going to distribute the power to every single factor that's inside. And this, again, is what we call the power of a product property, because I have a product, a multiplication problem, and I'm raising it to a power. So if I see an AB to the n power, then what that tells me is I'm going to take that n and I'm going to distribute the power, again, to every factor that's inside. So I'm going to go A to the n, B to the n, and that's what my power of a product property says. And basically, like I said, what it tells me is I'm going to distribute the power. Oh, shame on me. I'm going to distribute the power to every factor that's inside. I know, it's horrible singing, but I'm telling you, you will never forget this. I have students who I haven't seen in years, and they still sing, distribute the power. You'll never forget what this means. So let's take 3 examples here, and that'll wrap it up. So I've got this product inside this parentheses, 4 times y to the second. The whole thing is being raised to the third power. Remember, that the fact that that power is outside the parentheses means all of it is raised to the third power. So I'm going to distribute the power to every factor that's inside. That means I'm going to take my 4, raise it to the third power. I'm going to take my y squared, raise it to the third power. Now, remember, y squared to the third, we just saw up here, that means that when I take a power and raise it to a power, I'm going to multiply those exponents. So that's going to give me a y to the 6, because 2 times 3 will give me 6. And then 4 to the third, we are going to go ahead and evaluate that, because I know that 4 to the third means 4 times 4 times 4. Well, 4 times 4 is 16. 16 times 4 is 48. So I'm going to get a 48 y to the 6th out of that. Now, moving on to the last 2 examples. Wait a minute. 4 times 4 is 16. 16 times 4, oh, shoot, is 64. My deepest apologies. There we go. 64 y to the 6th. Okay, now, take a look at the last 2 examples that are there. Notice they look very similar, an awful lot alike. But there's a big difference between the 2. And what is that difference? Absolutely. This one has that -3 outside the parentheses. Is that going to make a difference in the answer? Totally, a big, huge difference. Because here, I'm going to take that third power and I'm going to distribute the power to every single factor that's inside, going all the way through that parentheses. So I'm going to distribute it here, here, and here. But on this one, when I distribute the power, it's going to go all the way through the parentheses, but it's going to get stuck at the end of the parentheses. So it'll distribute here and here, but not to that -3 that's outside. So in this case, I'm going to take my -3 and raise it to the third power. I'm going to take my A and raise it to the third power. I'm going to take my B to the fourth and raise it to the third power. Now, B to the fourth is 12, or B to the 12th, I'm sorry. A to the third is just simply an A to the third, and now we've got to deal with this -3 to the third. That's -3 times -3 is +9. +9 times -3 is a -27. So we get a -27, A to the third, B to the 12th out of that. Then in this last one, like I said, distribute all the way through, but not beyond the parentheses. It gets stuck at the end of the parentheses. So that -3 coefficient is going to carry over, and when I distribute that 3 exponent to the A, I get an A to the third, and then once again that B to the fourth to the third power, like we set up here, that's going to be a B to the 12th. So we will get a -3, A to the third, B to the 12th. And you can see, yes, makes a huge difference in the answer. My variables are the same, A to the third, B to the 12th, but the coefficients are completely different because this is a -27 and this one is a -3. Huge difference because of how far we distribute that power. Now, one last thing, that 2 to the 15th is really bugging me, so I'm going to figure out what 2 to the 15th is. Let me see here, 2 to the 15th is 32,768. 32,768 would be 2 to the 15th. 2 to the 15th. But like I said, the real point here is knowing these laws of exponents and what to do with them. So I hope it helps. Have a great day. Bye.